So the next speaker we have is Alex Soto. He is a software engineer at Red Hat, and he is a computer engineer, a Java champion, a teacher, an author, and a collaborator of a radio program.
Hello, everybody, and thank you very much for coming to this session about Hybrid Cloud for Java developers. And I'm going to share with you some links. So actually one link. So be prepared in the chat window, because it's there where I'm going to paste, because I'm going to need your help in this Hybrid Cloud journey. My name is Alex Soto, and from here, the important things to remain is that, first of all, is that link that you can see there, which is the Hybrid Cloud Java. This is the slides, so you can just go there and use the slides or wherever you want. And the second one is on the right side, which is my Twitter, and it's important because I'm these days with with all this lockdown and so on, we're going to share a lot of information about not only Hybrid Cloud but also Kubernetes, Tekton, Istio, and so on. So I mean that if you want to learn more about all this Hybrid Cloud wall and Kubernetes and so on, then I'm going to share a lot of content these months. So the first thing is that what is an Hybrid Cloud? And Hybrid Cloud is a cloud computing environment that connects a mix of public cloud, private cloud, and on-premises infrastructure. So basically, it's just it's very intuitive what it is, right? Because it's like, okay, now instead of having one cloud where I deploy everything, for example, I choose Azure, or I choose Amazon, or I choose Google Cloud. You choose one and you put all your applications there. And now we are changing this, and we're going to see why. So intuitively, what you can see is that we've got our cloud in Azure, and we deploy some services or all services there. And then we also have Google Cloud, and we put there some other resources. And then we've got Amazon, and we put there also some other services, resources, I don't know, databases, whatever. And then we've got our private cloud, right? In this case, it's the logo of Minikube, right? I know that nobody was going to use Minikube as a private cloud, but it just to give you the idea of what it means, private cloud, right? It's something that's running on your infrastructure and nobody from outside can access. It's it's on your own infrastructure. So let's start, and I'm going to share you the first link, which is it's this one. Where is the chat? Okay. Why I cannot see the chat window?
Are you using the app on the web?
Yeah.
Maybe under to the left, do you see something that says chat?
No, I just see maybe because wait, here participants more chat here. Okay, thank you. So this is the link. So please go to this link, which is this one, and you'll see an application. I'm going to explain you now how it works. Basically, it's an application that is deployed in 2 different clusters in Azure. It's in Google Cloud Platform and in AWS with a Kubernetes. Well, in fact, it's an OpenShift, but as you may know, OpenShift is Kubernetes, so it's a Kubernetes cluster. So you can do kubectl get nodes, and you see here that this is my cluster. It's in Paris, I guess, and it's composed by 3 worker nodes and 3 master nodes. This is just a Kubernetes cluster running on Europe. And here in the other screen, I can do get nodes. Oops. You've got all get nodes. It takes a little more time because this cluster is in Singapore, so it's in Asia, and you can see that it's in Google, it's not in Amazon, and it's in this case it's in Singapore. And in both clusters, I've got the same application deployed. I can do kubectl get pods, and you can see here that there is the application Hybrid Cloud backend. And if I do here a kubectl get pods, there is also the hybrid cloud backend. So I've got two, let's say two services, which is exactly the same service deployed in two different cloud providers, Amazon and Google, and both running in Kubernetes. And this is really important that it's running in Kubernetes. Then, if I'm coming here, you can see now, I see that you have started here playing a lot. I can say hello. And what you can see here is, this is the cluster who processed the message. So basically, you're just sending a request and it sends get back the response. You can see, for example, reverse and uppercase. And if I do aloha, you get it. Aloha, I don't know why it's not reversed. I see it's reversed, ahola. Okay, yeah, I read it that way. Yeah, so I mean that you can, I mean, it's really simple, right? It's just a service that it's just taking your request and doing in uppercase or not, and doing the reverse. Nothing really new if you wish, but let's continue a bit with the slides, and then I'll explain you a more fancy things. Let's continue. So, okay, yeah, it's okay. Then, what are the principles of hybrid cloud? So, why we need an hybrid cloud, or not why, but if you are going to hybrid cloud, what do you need to take care of? The first one is that you need a consistency of user experience. It means that if you are deploying your application in Amazon and you are deploying your application in Azure, you might want to have exactly the same tools. And this is why Kubernetes is really useful. Notice that I've done kubectl get pods in both clusters, and there was no difference. I didn't need to learn any new tool. I just deployed my Kubernetes cluster there, and it just works. The other thing that you need to take care of is that flexibility of deployment across hybrid and multi-cloud. You need to be able to deploy your applications in the same way. You cannot, deploy in one way in Azure and deploy in another way in Google Cloud, and so on. So what you need to do is just find a way to deploy in a standard way. And in this case, again, Kubernetes helps you a lot, because you can do kubectl apply -f, you put the deployment file, and you're going to execute exactly the same thing in any of your clusters. It doesn't matter if your cluster is in Google, doesn't matter if your cluster is in Amazon or Azure, doesn't matter, you will deploy all the time in the same way. Also, it's important that you need to stay open, right? Kubernetes is an open source project, so you stay open, but you might be able to choose other things. For example, what's happening if I want to deploy with Helm? Okay, use Helm charts to deploy. Doesn't matter. I mean that it's going to work in every cloud provider. So you need to be able to choose what tools you want to use. Although you are, in this case, using Kubernetes, you still need to have this freedom. You need to be able to access to the latest innovation. You don't need to stick to a version that you don't feel comfortable. You need to be able to update as you are developing. And for example, if you are using a PostgreSQL version and you want the latest and the greatest one, then you should be really easy to upgrade or move to that new version. The fifth thing is that there is a risk reduction, reality, and trust. It means that you need to trust of your cloud. And this basically implies that you don't need to use the lock-in features that are providing. So for example, if you're in Amazon, for example, you're going to start using S3, you're locking in to Amazon. You might need it, it's fine, right? But when you want to start moving your services from Amazon to Azure, then you might have some problems. We're going to see it later, how you can try to mitigate these problems, but this is one thing that you really need to take care. Try to stay out of the vendors lock-in. And as you've seen in these points, Kubernetes and in this case OpenShift, which is the Kubernetes for enterprises, really helps you on this hybrid cloud movement. What are the advantages of hybrid cloud? The first one is disaster recovery. What's happened if your Amazon cluster goes down, right? But maybe it's not because your fault. Remember that maybe it was like 4 or 5 years ago, there was some problem with S3. S3 goes down, and half of the internet were down, right? And it's not your fault. but you're still having some problems. So what's happening in these cases, right? You need to have another plan. Another one is lower latency. This is a really cool picture. You can see that it's in the supermarket. And what's happened if your cluster is far away from where your clients or your customers? Then it happens like when you're getting some high latency. You're having performance issues, not because of your application, but because the location of your cluster. So maybe sometimes you might need to have some kind of services located near your client, near your cluster, near your customer, and not in far away from where you are. And the third one is data sovereignty. This means that some governments require that your data, should be always in the same place. You cannot go out to another country. And what's happening, for example, your cloud provider are not providing infrastructure in your country, right? Then you might need to stick into a private cloud approach. So how we can manage all these different cloud providers to be able to feel that your application is like one application, although it's a hybrid cloud application. And the secret sauce is one project called Skupper. And basically what Skupper does is something like this. We've got all our cloud providers, all of them running Kubernetes. Each of these Kubernetes has pods and has a service, and then we are adding a Skupper in front. You can think of Skupper as a level 7 proxy application that allows to interact with several Kubernetes. So we install a Skupper in front of each of the services that we want to be synchronized, if you wish, between all the Kubernetes, and using MTLS and encryption creates like VPN. I mean, it's not a VPN, okay, but just so you get it the point, between all these services. So they automatically are providing connection between all the cloud providers. And what's even really interesting about Skupper is that provides fault tolerance capabilities, locality, and so on. So for example, you can configure Skupper to always send the traffic to the cluster which has a lower latency, or do retries to another cluster in case of an error. And let's go back to the demo. And this is the demo. I've seen that all of you are, no, there is no database. It's just, you send a request and it gets the response, but nice that you tried. Okay, then let me go here. And this is the Amazon. Notice that all the requests goes to Amazon. And now I'm going to simulate that Amazon goes down. I can do kubectl get deployment. Okay, I'm going to take this deployment. Okay, and I'm going to kubectl scale kubectl scale, and I'm going to put it 0 replicas. So basically what I'm just doing here is removing the service from Amazon. So I now can do kubectl get deployment, and you see that there is no backend. Okay, now please go here and start doing requests. I don't see any requests. Are you lazy? Aha! Notice who's serving the request. It's done by Google Cloud Platform. So now I can just go down, go up, and it doesn't matter. I've got my multi-cloud application, and thanks to a Skupper, I can, deal with all this stuff without doing anything. Notice that at the end, I just scale down or scale up. Now I can go here, and I can scale up again. Now it's like Amazon is recovered. So in my case, the preferred cluster is Amazon, because this cluster is in Europe. So for the latency, it's faster the Europe one than the Azure one. And then
Alex.
Yeah.
Sorry to interrupt. What page are we supposed to be seeing? Because right now I'm seeing the Hybrid Cloud, the link that you sent us. I think when you
Yeah.
clicked something else, I wasn't able to see it. The other tab you had?
Oh, no, yeah, it's normal. I mean, you should only see this.
Okay, perfect.
Yeah,
Thank you. Sorry about that.
Yeah, no worries. This tab is my OpenShift running on, in this case, is the Europe one, which you can see all that. Yeah, but this is the administration console. So you see that we've recovered it. Amazon has recovered it, and we go to Amazon again. So you're almost done because it's really quick session. And let's bring down. Let's see some of the points that maybe you have some questions regarding hybrid clouds. The first one is, please use Kubernetes and OpenShift to allow you to jump into the hybrid cloud demos or hybrid cloud movement, hybrid cloud architectures, and so on, because it's the way you can make a standard all your deployments, all your software, everything. It runs in Kubernetes. It works in every cloud provider. Then there is a Skupper.io. In a Skupper.io, you can see how this works, right? This proxy, how this proxy can be installed, and so on. Then I know that some of you will say, okay, and what's happening if I'm using a blob store, for example, S3, and then I want to move to Azure? Then there is one project, which is Apache G-Cloud, which is a Java project, which is an abstraction of this, let's say, cloud locking or vendor software, right? So G-Cloud is like an abstraction. It works more or less, okay, but it's not fully compatible with all the clouds and so on. But depending on what you're going to do, it's worth to take a look. And finally, of course, you can run this example, this hybrid cloud Java example, without any problem. If you go to github.com/redhatdevelopersdemos/hybrid cloud, you'll see there the instructions, the code, and so on, so you can take a look. Just remember that that all the containers has been already created. They're ready for you. So you don't need to compile anything. You just need to do kubectl apply, kubectl blah blah blah, Skupper init, and just works. And then Tim has a question. And that's all. I mean, remember, that's my Twitter. You can just ask me whatever you want in Twitter or even in email. You can send me an email. It's not a problem. If not, I will remove the mail from the slide. So just feel free to send me any email for any question. Then it's time for the questions. And I see Tim that is asking, have any companies used the likes of hybrid cloud? Just the most cases they will haggle for a discount on a cloud provider. Well, yeah, this means that you've got, if I understand correctly, the question is that, okay, you've got two clouds and you're paying double. Sorry, sorry, you're paying double or whatever. Well, yeah, this might happen, but at the end, it depends of how your business is, right? If your business is really important, you don't want downtimes because of any problems, then you might want to have two cloud providers in different regions. It's not necessarily two different cloud providers. Maybe you want to have just two clusters running in two different regions. Maybe you want just like that. Okay, then it works as well. Or sometimes it's, as I said, there is other use cases. For example, data sovereignty. What's happening if your client is in a country that they don't want to move out his data, but your application is running in another cloud provider? Then probably you might want to do some kind of private cloud on your customer and your client, and then have your public cloud in another place. So yeah, of course, it depends. I know that it costs money, right? That's true, but you have other advantages. I said, does Skupper interact with Envoy? Does Skupper interact with Envoy as Skupper is using an Apache project under the covers, so it's not an Envoy proxy. It's another kind of proxy. It's from Apache Qpid, and I don't remember exactly which proxy is, but I think that it's not an Envoy. Also notice that it's a different approach than the Envoy. If you're asking this, for example, for Istio, notice that here I've got my application and the proxy, right? There's two different things. In case of Istio, you've got your application and you've got both of the proxy and the application on the same pod. In this case, I have two pods. It's a different approach. Let me check if it's come back to live. Suppose it, yeah. Also, if you want to see another cool demo, that I think that we've got like 5 minutes, I'm going to show you how you can use Skupper for connecting with a private cloud, which is it's a really cool example. Let me, I've got here my Minikube. Notice that I do get nodes. See that this is my Minikube with just one node, and then I can do kubectl, get pods, and I've got nothing, okay? Now I want to deploy my new application. The first thing that I need to do is create a tunnel. I need to create a tunnel because, you know, my mini, you cannot see my terminal now?
I see your PowerPoint.
Yeah.
Oh, okay, wait, wait. Why? Now?
No. Still seeing your PowerPoint.
Because, wait, stop sharing, share screen. Why? I want to share my second screen, but it seems that that's not. Why not?
So I think what happened earlier when you were trying to share your terminal is we couldn't see it either. When you click share screen.
Yeah, but I can only, why are you gonna choose the desktop? Okay, weird. No. Because if I choose this and do share, now I'm sharing my, again, the application and not the desktop. You share. Okay, problems. Let me stop. Why not share? But why you cannot choose a desktop? I can only choose. It's strange because I can only choose. I can only choose.
Let me see if I'm able to share my desktop, just to see if maybe if I make you a co-host, you could do that. Oh, you're right. Okay, I see. Computer sound optimized. That's strange. When we tried it before, we were able to share the desktop.
But now it's only okay. Well, it doesn't matter. Look, I'm going to share the term. Now you can see the term, the terminal. So okay, then I'm going to create this tunnel. Minikube terminal USP. So I'm just creating like a connection between my public IP and my Minikube that is running inside my machine. I need to put here the password, and then there it is. It is my terminal there. Then I'm going to deploy my service. Kubectl apply backend Minikube. So I'm just deploying the backend. Now it's running, and then now let's see what they need to do. The first thing that they need to do is annotate the service hybrid cloud backend, which is the backend, with this skupper.io/proxy equal HTTP. So I'm just saying, hey Skupper, when I install you here, please use, use this HTTP thing. Okay, I just annotated the service. This is a Kubernetes annotation. Then I can do kubectl. Oops, kubectl. No, I can just Skupper init. So I'm just initializing the Skupper. Hope that it works, because sometimes when I just remove and so on. Okay, now you notice that I've got the backend, the proxy, and so on. And the last thing is like I need to connect my Skupper proxy, my service, to all the Skupper mesh. And to do that, I need to do connect, and I got a token. This token is created when you create all this mesh with a Skupper. It creates this token, and this token needs to be shared with all your clusters. Now, notice I'm saying that the Skupper is configured. Now, let's go again. I know that go to the please go to the Hybrid Cloud application and do some message. I'm going to do one.
Alex, sorry to interrupt you. I think now you can share your whole desktop if you need to. If not, what you're doing is fine too.
Okay, I'm going to, yeah, wait, I'm going to share it in a moment. Share, but why not? Well, anyway, I'm going to stop. Okay, now you can see here that it's Amazon, and I'm going to do the same thing that I've done before, which is scaling down the deployments, so nothing new. So now I've scaled it down Amazon. I can go here again, and now it's Google Cloud. We could say BBBB, it's Google Cloud. And now what's happened if I scale down? I do exactly the same, but scaling down the Google Cloud. I'm just scaling down. It takes a bit more time. I've scaled it down, and now this is the funny thing. You're connecting into my Minikube. So this is what when I say that with the Skupper, with Hybrid Cloud, you can connect public clouds and private clouds. This is my Minikube private cloud. I've got my public clouds in Google and Amazon, and they're going down, and doesn't matter. It's my private cloud who is taking all the requests. And it's some kind of magic, if you will, but yeah, it works. And that's all that I have now. I have a question. Manuel says that you don't see. No, now you should not see the terminal, but the browser. Okay, and that's all.
Thank you so much, Alex. I have one last question, and then I'm going to give everybody a moment to go to the bathroom or refill their drinks. I had one sent to me here. Let me just check. Okay, so how can we use Skupper to access the private network? I think you may have already even mentioned this.
Yeah, you've seen here with the Minikube example, which is just a matter of passing this token, and if you share this token to all your clusters, then a Skupper, it just connects and do all the stuff without having to manage. The good thing is that you do not need to manage any kind of firewalls and nothing. It just works at level 7, and yeah, you can. It works pretty well. And I know that some people might be worried about the security, but it just uses MTLS and encryption, so it's secure.